Hello, fellow problem solvers. So today we're going to be doing a problem from the Polish team selection test from the year 2000, problem number 3. I suggest you try this amazing number theory problem out for a minimum of 45 minutes, ideally an hour and a half to 2 hours, not more than 4 hours if you'd like to go along with us and give this beauty a go for the next 20 minutes. And now let's begin. The reason I call this a beauty is because also here, I just want to say something about problems that are number 3, number 6 in many competitions, especially team selection tests. I know I've had this when I was competing, especially on the IMO level, is these problems are considered the hard ones on the exam. And so sometimes people have a thinking like, oh my God, how can I ever approach these problems? Because you don't really try them out, you don't see a lot of your solutions, and I'm hoping to give this with you to get you comfortable with these difficult, the hard problems, right? See that this is not something beyond human. And this is especially the case with this problem. And the reason it sounds quite scary is because this sequence, look how it's defined. P1, P2, okay, are given as primes. And then the next prime number is defined as the greatest prime divisor of this thing right here. And then prove this thing is bounded? Like, how am I supposed to know how primes behave? Do I need to figure something out about the distribution of primes? And the answer is probably not. At a competition, at a math competition, you're probably not going to prove a result that will give you a Fields Medal. You're competing on a high school level competition, so you don't need to. And this actually gives you hints as to what it is you can't, what it is you maybe shouldn't go ahead and try to prove. For example, anything about the distribution of primes after you have two of them that are given. Anything about the distribution of these primes seems to be a bit ambitious to try to prove, right? So that's what we're going off of here. So we need to start off thinking simply with these problems. And that is sort of the first thing. What do you notice? So Pn is going to be the biggest prime divisor of this number right here. So what do we know about this number? Well, the answer is we know this number is, in most cases, going to be even. Right? If Pn minus 1 and Pn minus 2 are not 2, then this number is even. And then its greatest prime divisor is going to be half of this. Right? It's going to be at most half of this. And let's also just look at the case like when one of them is 2, like say Pn minus 1 is equal to 2, and then Pn minus 2 is some prime number P. What happens in that case? We get ris prime of P plus 2002. This can then be, say this is some odd prime number Q. It's definitely not an even one. Like the greatest prime is this Q times some M, where M isn't prime, or is prime, doesn't matter, but this is the greatest prime divisor. And then we have Q plus 2002. Actually, then we have then Q plus 2002. And what Q gives us is another thing which is going to be odd. So we're going to have another prime number L times some K. But it seems like it doesn't matter if there's a 2 at some point. We're going to have maybe something to think about, but most of the time there ain't gonna be a 2. Maybe we need to look at the 2 consecutive ones, like how they behave. Like what is P plus 2002? Okay, Q can be equal to this, but among say Q and this next one L, maybe something else holds true. For example, I don't know, maybe L is smaller than P or bigger than Q or smaller than Q, something like maybe we can figure out something there. But let's look at this problem in general terms. What do we have? We have that, generally speaking, Pn is going to be less than Pn minus 1 plus Pn minus 2 over 2 plus 1,000, generally speaking, right? Because it's very rare. Like this is Pn is equal to 2 if and only if like this number here is a power of 2. That's going to be exceedingly rare. We will need to look at this, but for our own thinking at the current moment, let's just focus on this. And here I actually invite you to pause for the next 15 minutes and try to see if you can push the problem further, get some ideas and put them out on paper. And now here's the next sort of thinking. So I know this about Pn. I need to show that this sequence is bound, right? That there's some C, that this prime number never goes over that C. And sort of what this is telling me is this next prime number is going to be less than or equal to the arithmetic mean between these two primes plus some constant-ish thing. We'll say these two things. Say like the sequence is bounded by some C at some point, right? Say they will never go over this C until this point, then it's sort of like, I mean, this is going to be less than, and we have this will be less than, say, C plus 1,000, right? If it's bounded by some C. But if numbers C through C plus 1,000 are all composite, and we can make it so, then we know that Pn will also be below this number C plus 1,000. So that actually maybe could be a way for us to actually go ahead and solve this problem, which is to say, let's say that this is less than or equal to like P1 and P2 are less than or equal to some C factorial, maybe 2,000 plus C factorial for some C, just to make sure like that I don't get over this in any stretch of the way, and let's call this number like some D factorial. Now, and assume that these two numbers are less than or equal to this, right? Then this D factorial. Let's say actually 2010, just in case there's a +1 or a +2 somewhere here. I don't want to deal with that case. Let's just say plus like 2010, like that's my D. And then I know that Pn is the greatest prime divisor of Pn minus 1 plus Pn minus 2 plus 2000. Now I want to sort of say that these two numbers, like I can't, well, if I see it like this is less than or equal to D, this is less than or equal to D, that's not what I really want. I want to say that this number, like this isn't going to be a power of 2. Actually, what I'm saying is this isn't going to be a power of 2. But maybe then there's something to do with this Pn that we can say maybe this Pn is bigger than or equal, like less than or equal to the bigger one. Actually, it's roughly less than or equal to the bigger one of these. Though actually, wait a second. Even if this is, what am I doing? Even if this is a power of 2, no, the problem is if one of them is even, if Pn minus 1 is, say, even. That's where the problem meets. That's where you get a problem. But if we get a problem there, this will still not be a prime. Right? The problem is like, will this ever be a prime? Can we divide by 2? If this is not a prime, we can sort of divide by 2. And even if we have an even number, we know that this will be less than or equal to D factorial. Like say this is equal to 2. Then we have P plus 2002. Then this is going to be less than D factorial plus 2002. This Pn. We know this is less than D factorial plus 2002. So we're going to, because it's a prime, it's less than or equal to this. It's still less than D factorial. And so it's bounded. Now, what I invite you to do is to figure out a way to get these ideas. I've given you like here these like sort of hints, little breadcrumbs of an idea of how to think about the problem and how to deal with it. Why I love this is I didn't say anything about the distribution of primes, right? I just used, was the divisible by divide by 2, square prime divisor, it's a very weak estimate. And I'm using this fact that I can have as many as I want consecutive composite numbers. A finite number of them, of course. But with that, I invite you to pause for the next 20 minutes and try to see how would you take these ideas and formalize them. And I'm going to clear the board, and this is how we're going to do that. We say, let Qm be the bigger one of these two. And then we prove via induction that, say, Qn plus 1 is less than or equal to Qn plus around, say, 2002. And we go with our claim. If both of these are odd, then Qn plus 1, like mind you, if Qn plus 1 is equal to Qn, this is obviously true. If it's not, then we're saying Pn plus, actually we're saying Pn plus 1 is bigger than Pn. But then we have Qn plus 1, or is equal to Pn plus 1, which is going to be less than or equal to the sum of these two, Pn minus 1 plus Pn over 2 plus 1,000, which is going to be less than or equal to, given this is the max, of Qn plus 8,000. And so in that case, this inequality is true. If one of them is even, then we have Qn plus 1 less than or equal to Qn plus 2002. And that proves this claim that these numbers can't jump up too much, right? That the bigger one of these two can't jump up than the previous bigger pair. And it sort of formalizes these both cases when we have an evens and both odds. We ever run into powers of 2. And now we say we take d equal to say 2022 factorial times sum, or 2022 factorial, k plus 2022 factorial, such that d is bigger than both p1, p2, or that it's bigger than b1. And then we'll prove that d is always bigger than all of these numbers. And we prove that by saying this is true. We know this is true. We know Qn. We're going to prove that d actually is greater than Qn. Is the easiest way to prove this. Take a k such that d is greater than Q1. Assume d is greater than Qn. Then we have d is greater than Qn, which is going to be greater than or equal to Qn plus 1 minus 2000, or actually this plus 2000. D plus 2000 is greater than Qn plus 1. And now what do we say? If Qn plus 1 was bigger than d, then we would have that Qn plus 1 is bigger than d, but it's less than d plus 2002. And given this, it's a contradiction because there are no, actually d plus 1 could be it. So let's just write d as this plus 2. This is why we had a plus of 2002. D is equal to this. And now every number between d and d plus 2002 is composite. So Qn plus 1 could not be that number. Can't be equal to any one of those. That would be a contradiction. And so Qn plus 1 needs to be less than d as well. And this finishes up the problem. It's a cool number theory problem. It sounds very scary, the distribution of primes. And I think it's one of those problems that you have to try out to get to the next level in number theory, to get more comfortable playing around with problems. This finishes up our number 3 from the Polish team selection test in the year 2000. And as always, thanks for problem solving.